In this video, we'll be doing more examples of solving log and exponential equations. When solving log equations, the first thing we want to do is isolate the log. We want to get the log all by itself, meaning that anything inside of the parentheses and this base is part of our log function. So anything outside of that is what we want to get rid of, like this 3. So to get rid of the 3, it is 3 times this log, which means we're going to divide both sides by 3. So once we've divided both sides by 3, we end up with log has a base of 2, argument of x plus 5, and that equals 4. Now that we've isolated the log, the next thing we want to do is change forms, or in other words, use the inverse. So remember that the inverse of a log function is an exponential function. So 2 is the base, 4 is the exponent, and x plus 5 is the argument. Now that we've changed forms, we then want to solve for the variable. So 2 to the 4th would be 16. So 16 equals x plus 5. We would then subtract the 5, and we'd get that x equals 11. Now you always want to check your answer just to make sure that if you plug in the 11, you're not trying to take the log of a negative number. So when we plug in 11, we get 11 plus 5 is 16. We're taking the log base 2 of 16, which is a real number, so this is a correct answer. Here's your second example. So again, the first thing we want to do is isolate the log. Now, notice in this case there are 2 logs and they're both on the same side. So our step for isolating the log means that sometimes we need to condense these logs into one single log. So remember that when you are adding 2 logs, we can condense it into a single log by multiplying the 2 arguments. So we have x squared minus 6x. Now that we've brought it down into a single log, we can then change forms. Meaning, use the inverse, change it to exponential form. The base is 4, the exponent is 2, and the argument is x squared minus 6x. Now we're on to our third step, which is solve. So we are going to solve for x. Because we still have an x squared, we're going to have to factor. So 4 squared is 16, and that equals x squared minus 6x. We're going to subtract the 16 to the other side because we need to factor. So we've got 0 is equal to x squared minus 6x minus 16. So we need the multiples of what multiplies to negative 16 and adds to negative 6, and that would be a negative 8 and a positive 2. So we'd have x answers of 8 and negative 2. Which leads us to our fourth step is we need to check these answers to make sure that they do work. If I plug in 8 for the x's, I would have log base 4 of 8 and log base 4 of 2, which would be fine. If I plug in a negative 2, I'd have log base 4 of negative 2, and that is undefined. We can't take log base 4 of negative 2, so this answer does not work. It's what's known as an extraneous solution. All right, here's our last example. We're dealing with an exponential function this time. So we still want to follow the same steps. We're going to isolate the exponential. By isolating the exponential, it means that the base and the power, this whole thing counts as the exponential, which means anything outside of that I have to get rid of, like this 2. So it's 2 times our exponential, which means I need to divide both sides by 2. That leaves me with 3 raised to the x minus 5 equals 6. Second thing I want to do is change forms, meaning use the inverse. So the inverse of exponential is a log. So we have log, the base is 3, the argument is 6, and the exponent is x minus 5. Now, log base 3 of 6, remember to put this in your calculator, you need to use change of base. So we'd have log of the argument divided by log of the base. And remember that when there's no base written for log, it means that the base is 10, common log, which is what your calculator uses. So when you type in log of 6 divided by log of 3 into your calculator, you get an answer that's approximately 1.63. So we'll just round to 2 decimal places, 1.63. That equals x minus 5. Now we're going to add 5 to both sides, and we get the answer that x is equal to 6.63.